Hello students, welcome to Shri Classes, lecture number 3. Today we are going to study the Iupac nomenclature for alkanes, alkenes, alkynes and alkyl substituents. So let us begin the chapter. Iupac refers to International Union of Pure and Applied Chemistry, and Iupac nomenclature is how to write and how to read the names of the hydrocarbons. There are certain set rules and we need to follow the rules for reading and writing the hydrocarbons. What is that it consists of? Generally, the compound name may consist of prefix, word root, primary suffix and secondary suffix. Prefix refers to the phrase used before the word root and it is used to indicate the functional group. Suffix refers to the phrase that is used after the word root, and primary suffix indicates the type of linkage in the carbon atoms and secondary suffix indicates the functional group. What are these functional groups? We will study in our next lecture. What is word root? Word root refers to the word root meaning. Here you can see meth, eth, prop, but, pent, hex, hept, oct, non, dec. These are the root words or word root. Sometimes we use root word or sometimes we use word root, but the meaning is same. So the root words are meth, eth, prop, but, pent, hex, hept, oct, non, dec. What are these names for? These names are given to hydrocarbons if the number of carbon atoms, see the root word name is given based on the number of carbon atoms present in a parent chain. What is a parent chain is the longest possible continuous chain of carbon atoms is called the parent chain. What is the parent chain? Once again, the longest possible continuous chain of carbon atoms is called the parent chain, and the number of carbon atoms we have to count based on the number of carbon atoms present in the longest chain. The root words have been decided. If the carbon compound contains only one carbon atom, then the root word is meth, M-E-T-H, meth. If the parent chain or the compound with the parent chain has two carbon atoms, then eth is the root word. If the compound contains 3 carbon atoms in a parent chain, prop is the root word. If the compound containing parent chain is having 4 carbon atoms, then it is but. So here all these 1, 2, 3, 4, 5, these indicate the number of carbon atoms present in a parent chain. Based on the number of carbon atoms, the root word fixed is meth, eth, prop, but, pent, like that. If there are 9 carbon atoms in a parent chain, the root word name is non. If there are 10 carbon atoms, the root word name is dec. So I hope this you are able to understand very clearly. That is, based on the number of carbon atoms present in a parent chain, the root words names have been decided. I hope this is clear. Next is, what is this suffix? As I said, suffix refers to the phrase that is placed after the root word. Primary and secondary, there are two kinds of suffixes. Primary suffix refers to the type of linkage between the carbon atoms. If between two carbon atoms there is a single bond, in that case we use the primary suffix as ane, ane, after the root word. Meth, ane, methane. Eth, ane, ethane. Prop, ANE, propane. If between two carbon atoms there is a double bond, then we used the suffix "ene", ENE, after the root word. Here, in order to have a double bond, there must be two carbon atoms, and therefore the primary suffix when we use "ene", it should start with two carbon atoms, that is ETH. Meth and ene, it is not possible to combine, because in meth the number of carbon atoms is only one, whereas in eth you find two carbon atoms, and definitely we can have either a single bond or a double bond. If a single bond is there, ethane, ethane. If double bonds are there, then eth, double bond if it is there, add ene, ethene. After eth, put this in ethene. Prop, in propene. But, in butene. Pent, in pentene, like that. Similarly, if there are three bonds between carbon atoms, we add primary suffix as "wine" after the root word. Eth, wine, ethyne. Prop, YNE, wine, propine. But, YNE, butane. Pent, YNE, pentine. Hex, YNE, hexine. This is how we add the root words and the primary suffixes joined together forms alkanes, alkenes, and alkynes. Once again, meth, ane, methane. Eth, ane, ethane. Prop, ane, propane. So when we add ane after the root word, the compounds are called alkanes, and all these alkanes are saturated hydrocarbons. The alkenes and alkynes will start with eth root word. Remember that. So if there is a double bond between carbon atoms, then eth, ene, ethene. Prop, in propene. But, in butene. Pent, in pentene. Like that, the names will start. If there is a triple bond, then eth, wine, ethyne. Propine, butane, pentine, hexine. This is how the nomenclature starts. For alkanes, alkenes, and alkynes, only the word root and primary suffix is enough. For functional groups, if the hydrocarbon contains the functional group, then we may require prefix and secondary suffix, which we'll see after studying the functional groups. Now let us try to understand how to write also alkane series, alkene series, and alkyne series. These series are also called the homologous series. Homologous series refers to the compounds which are derived from the same general formula and which contain the same functional group. See, all these single bond, double bond, triple bond, these are also come under functional groups only. So let us try to understand how to write the names for alkanes, alkenes, and alkynes in our next slide. Here, let us see how to write alkanes. Alkanes are saturated hydrocarbons. The nomenclature consists of word root or the root word plus primary suffix. As alkanes contain only a single bond between carbon atoms, the primary suffix used is ane, alkane. And what is the general formula for alkanes? The general formula for alkanes is CnH2n plus 2, where n refers to the number of carbon atoms. N refers to the number of carbon atoms. Suppose n equals 1, then substitute here C1H, 2 into 1 is 2 plus 2, 4. C1H4. 1 generally we need not write, CH4. If N equals 1, then the molecular formula of the compound is CH4. What is the structural formula? First write C. There are 4 valencies and hydrogen is to be attached to the carbon atom through those 4 valencies. So this is the structural formula for CH4. What is the condensed formula? The abridged formula. The condensed formula is, for example, here this is the structural formula and condensed formula for this is CH3 bond CH3, CH3 bond CH3. This is what the condensed formula. For of course, for methane there is 1 carbon atom only, and therefore we write the condensed formula as CH4. Same as the molecular formula. What is the Iupac name? Iupac name consists of the root word and the primary suffix, that is ane. How many number of carbon atoms are there? Only 1 carbon atom in this compound. So the root word is meth. And what is the primary suffix? Of course, there is only 1 carbon atom, and therefore this also forms with all these elements only single bond, and therefore we add primary suffix as ane there, that is methane. Let us take the second case. N equals 2. If N equals 2, what is the general formula here? 2 into 2 4 plus 2 6, C2H6, C2H6. This is the structural formula. There are 2 carbon atoms. Between carbon atoms there is a single bond because we are talking about alkanes, and hydrogen is to be balanced based on the valency. Like this is 1 bond, first bond, second 1 2 3 4, hydrogen you balance it. For this is 1 2 3 4. So because 4 valency is there are 4 valencies, so the valencies must be balanced like 1 2 3 4 like that. So this is C2H6 structural formula. Condensed formula CH3 bond CH3, CH3 bond CH3. What is the Iupac name? How many carbon atoms are there in this? 2 carbon atoms. Therefore the root word is ith. If there are 2 carbon atoms, the root word is ith. And what is the bond linkage between carbon atoms? Single bond. Therefore primary suffix is ane. So ith, ane, ethane, ith, ane, ethane. I hope this you are able to understand. So let me try to write on the board this formula once again for your understanding. Now let us try to write the alkane series. This is also a homologous series, and homologous series refers to a series of compound which are derived from the same general formula. So alkanes what is the general formula for this? First Iupac nomenclature, or first let me write the general formula CN H2N plus 2, and Iupac name is Iupac name is root word and primary suffix. First is root word and plus primary suffix, and this primary suffix here in this case is ane. Ane is to be added after the root word. So let us take N equals 1, first compound N equals 1. Apply the general formula C1 H, 2 into 1 is 2 plus 2 4, CH4. So this is the molecular formula. Molecular formula. What is the structural formula? Structural formula. Carbon place here and 4 valencies are to be balanced. 1, 2, 3, 4. There are 4 hydrogen atoms. Write it. As there is only 1 carbon atom, this is suffix ane is to be added over here. How we have written there? A condensed formula and Iupac name. Okay. Here I write the condensed formula. condensed formula, which is CH4, and finally here name of the compound we'll write. This name is Iupac name, basically Iupac name. There are two types of names here. One is the common name and Iupac name. So let us try to understand what are the Iupac names for this. CH4, how many carbon atoms are there? Only one. If carbon atoms are only one, here I'll write number of carbon atoms and root word. If one, it is meth. Is it visible there? This one? Okay. So here I'll write number of carbon atoms and root word. 1 meth, 2 eth, 3 meth eth prop, 4 but, 5 pent. These are the root words. Only one carbon atom is there, and therefore here it is meth. And there is all single bond only in this one. So this is ane, methane. Let us take N equals to C2H. What is the general formula? Cn H2n plus 2. 2 to the 4 plus 2 6. H6. How do you write this one? Write one carbon atom and another carbon atom. Then balance the valencies. 1, 1, 2, 3, 4. 1, 2, 3, 4. Put H here. Okay. Condensed structural formula. CH3 bond CH3. CH3 bond CH3. How do you read the name of the compound? This is the longest chain amongst this one, and therefore there are two carbon atoms, and this is called a parent chain, and there are two carbon atoms, and therefore if two carbon atoms are there, ETH, eth is the root word. So ETH is the root word, and ane should be added as a primary suffix because there is a single bond linkage between carbon atoms, and therefore ethane. Next, third one, N equals 3, formula C3H, 3 to the 6 plus 2, 8. How do you write the structural formula? 1, 2, 3. First write the carbon atoms with connect with single bond and balance the valencies. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4 and put H. Is it clear for all of you? Okay. Next, what is the parent chain? This is the longest carbon chain, and therefore this is a parent chain. Number of carbon atoms, 3 are there. What is the root word? Meth, eth, prop. Prop is the root word. But let us write first the condensed formula. CH3, CH2, CH3. CH3, CH2, CH3. This is the condensed formula. Let us name it. What is the Iupac name? 3 carbon atoms. Root word prop, P-R-O-P, prop, and ane, because single bond is there between carbon atoms, ane. It is called propane. One more I'll take as an example. N equals 4, C4, H10, 4 to the 8 plus 2, 10. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Put hydrogen. Condensed formula CH3, CH2, CH2, CH3. CH3, CH2, CH2 and CH3. What is the parent chain? This is the parent chain. How many carbon atoms? 1, 2, 3, 4. Root word for 4 carbon atoms, but. But. All these are linked with single bond, therefore ane, butane. So this is how we name the alkanes, and this sequence continues. Like carbon atoms for n equals 5, n represents the number of carbon atoms in a parent chain. So n equals 5, it is pentane. N equals 6, hexane. N is equal to 7, heptane. N is equal to 8, octane. N is equal to 9, nonane. N is equal to 10, decane. And it will continue. You got it? So I hope how to write these things you have understood. So I will direct once again to the PPT, make a good notes out of that. So make a note of all these things. Molecular formula, first alkanes, right? Alkanes, saturated hydrocarbons, and Iupac nomenclature consists of root word and primary suffix "-ene", and the general formula, all these compounds are derived from the general formula CnH2n plus 2. Okay, and these are what are these things? These are the alkanes. N equals 1, 2, 3, 4, 5. For alkanes, we'll begin with N equals 1. For alkenes and alkynes, which are unsaturated hydrocarbons, the starting number of carbon atoms is 2. It starts with 2 basically for alkenes and alkynes. So these compounds are called alkanes. Okay, make a note of this. Now let us study alkenes. These are unsaturated hydrocarbons. Iupac nomenclature consists of root word plus primary suffix. The name of the primary suffix or the phrase of the primary suffix is "ene", "ene". Why it is so? Because the carbon linkage will be having a double bond. Here if you see all these compounds, there is a double bond between the carbon atoms. At least one double bond must be there. What is the general formula? How do you derive the molecular formula? General formula CnH2n. So molecular formula, structural formula, condensed formula, Iupac name. Let N equals 2. As I said, alkenes and alkynes begin with N equals 2. Why it is so? Because we need to have definitely at least one double bond between carbon atoms. In that case, there must be 2 carbon atoms in order to have a double bond. So N equals 2. Substitute N in this formula. C2H2 into 2, 4. C2H4. C2H4 molecular formula. Structural formula. Carbon, carbon, double bond. Count the valencies. 1, 2, 3, 4. Hydrogen, hydrogen. This carbon atom. 1, 2, 3, 4. Hydrogen, hydrogen. Condensed formula. CH2 double bond CH2. Iupac name. This is the longest chain. Number of carbon atoms 2. Therefore, root word eth. ETH, eth. Primary suffix "-ene". Eth, "-ene", ethene. Therefore, the name of the compound ethene. So I'll write these things once again on the board and explain. Then you'll be directed to the PPT for making notes. Here, let us write Iupac nomenclature for alkenes. Alkenes are unsaturated hydrocarbons consisting of double bond between carbon atoms. General formula CnH2n. Iupac nomenclature consists of root word and primary suffix "-ene". So let us start. First one, N equals 1, it is not possible. How will you be able to form a double bond in single carbon atom? You cannot represent like this. It is not possible. Why it is not possible? Do you think this bond is nothing but it is not simple straight line. Each bond represents one pair of electrons. Even though carbon has some electrons, what about hydrogen? Can you get one more hydrogen electron here? Not possible, no? Hydrogen has got only one electron, and therefore it would be able to share only one electron with carbon, isn't it? Therefore, you cannot have a double bond between carbon and hydrogen. Now, in order to have a double bond, definitely I must have one more carbon atom. That is possible, and therefore the naming for alkenes start with N equals 2. So first compound N equals 2, molecular formula C2H4, structural formula. First write one carbon atom, introduce a double bond, match the valencies for 4 valencies 1, 2, 3, 4, 1, 2, 3, 4. Put hydrogen here. Okay. Condensed structural formula CH2 double bond CH2. CH2 double bond CH2. What is the Iupac name? Iupac name is, this is a parent chain, the longest possible chain. Number of carbon atoms 2, therefore root word eth, double bond, primary suffix -ene, ethene, 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 which is ethene. Next one, N equals 3, C3H6, 1 double bond 2, 3. You can have double bond here also, it will not make any difference, either here or here. Only once you have to indicate the double bond, otherwise valencies will not match once again. So carbon, 3 carbon atoms, introduce one side double bond and one single bond. 1 2 3 4, 1 2 3 4, 1 2 3 4. Hydrogen. Yeah, how many hydrogen are there? 1 2 3 4 5 6 hydrogen atoms. How do you read this one? CH2 double bond CH, single bond CH3, CH2 double bond CH, CH2 double bond CH, single bond CH3, single bond CH3. How many carbon atoms are there? There are 3 carbon atoms, therefore root word prop. Double bond is there, ene, propene, propene, the name of the compound is propene. Next, N equals 4, C4H8, 1 2 3 4. Now I'll introduce this side. You can introduce this side also, it's okay, I mean it will not make any difference, but there is possibility of introducing double bond here also, and therefore see here we come across something called isomers. What are isomers? Isomers are the compounds having same molecular formula but different structural formula. Due to change in structural formula, their properties will be different, and therefore isomerism also can be used as one of the terms for carbon to exhibit large number of compounds. So this, let us concentrate only the naming front now. C4H8, 4 carbon atoms. I need to introduce one double bond. I will introduce over here. Now 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. This is how the valencies for hydrogen atoms need to be counted and managed. Put hydrogen everywhere now. Check whether hydrogen atoms are correct or not. 1 2 3 4 5 6 7 8, C4H8. How do you write the condensed formula? CH2 double bond CH, single bond CH2, single bond CH3, CH2 single bond double bond CH, single bond CH2, single bond CH3. So CH2 CH, CH2 CH3, CH2 CH, CH2 CH3. Here it is double bond. This is the parent chain, maximum number of carbon atoms. Why this is called a parent chain? Because the longest possible continuous chain of carbon atoms in a hydrocarbon is called a parent chain. Why it is so? See, you may end up with some branched chains also, which we are going to study later, but for the time being this is the longest chain. Number of carbon atoms are 4 here. 4 is root word but. For 4 number of carbon atoms in a parent chain, the root word is but. Is there a double bond? Yes, there is a double bond. Ene is the primary suffix. Butene. Now here one very important thing here. See, there is a possibility of shifting this bond, double bond, here or here or here. Putting double bond over here or here, it will not make difference, but the bond can be put here also. See here, I will explain one more this thing here. 1 2 3 4 carbon atoms. Here in the beginning I put double bond here, but I can definitely put double bond here also. In that case, this is single bond, this is single bond. 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. This is how one more compound will be formed. Okay. Now, see, there is a numbering system involved, and the numbering should be done in such a way that wherever there is a double bond, that should get a least count for carbon atoms. The numbering system involved will be to number those carbon atoms to which these double bonds are attached. Now, I can count this for like this also: 1, 2, 3, 4. The parent chain can be numbered like 1, 2, 3, 4, or I can number from this side also 1, 2, 3, 4, which is correct. Wherever there is a double bond, that double bond carbon atom should get the least count. Here, in this case, from the top side, if you read the numbers, the carbon atom is the first carbon atom to which the double bond is attached. But if I read from this, the lower side, then fourth carbon, this is the third carbon atom to which the double bond is attached. Just before the double bond, the carbon atom is to be counted. So if I come from this side, for third carbon atom, the double bond is attached. If I go from left to right, for first carbon atom, the double bond is attached. And therefore, that numbering of the parent chain is correct, where the double bond attached to the carbon atom should get a least count, and therefore my numbering system over here is correct and this numbering system is wrong. And therefore, while naming the compounds, the ene, that is double bond, ene is a primary suffix to double bond. So the ene to which carbon atom it is attached should be represented with hyphen. For example, the double bond here is attached to the first carbon atom, ene to first carbon atom. So but hyphen 1 hyphen ene. This is the correct Iupac name, but 1 ene. Also acceptable is 1 hyphen butene, but not recommended. According to latest Iupac rules, this way of writing, it is not recommended. Probably about 5 years back, it used to be acceptable. Now also there is nothing wrong in writing like this, but Iupac recommends this way of writing, where this double bond is attached to, but 1 ene. Now, you may ask me, if I put a double bond over here, what happens? Let us take once again one example here, 1, 2, 3, 4. Let me add a double bond here and single bond, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. These are hydrogen. All these are hydrogen. Okay. How to number the parent chain? The longest chain is the parent chain. How to number it? I can have a numbering 1, 2, 3, 4. I can have a numbering 1, 2, 3, 4. The double bond should get the least count. Carbon, the double bond attached, if I read from the bottom, for first carbon atom, the double bond is attached. If I read from the top, for third carbon atom, the double bond is attached. And therefore, the correct method is this method, but not this method of numbering the system. If this is the method of numbering the system, how do you read the compound? Parent chain, 4 carbon atoms, meth, eth, prop, but. But is the root word. And double bond contains ene is a primary suffix, butene. But ene is attached to which carbon atoms? First carbon atom. Therefore, for this also, but 1 ene. Is there a difference between these two? Absolutely, there is no difference. And therefore, putting a double bond at this extreme side or at this extreme side, it will not make a difference. These two carbon compounds are same. Is it clear? Now, I can have an option of putting the double bond here. That is in between this. Now, how do you name this? From this side, if I name, see, these carbon atom, the naming of the system, you cannot start, from here, 1, 2, 3, 4. No, it is not like that. Once if you have a longest carbon chain, either you have to start the numbering only from one end of the from one end of that carbon chain or a parent chain. So here one way is 1, 2, 3, 4. You got it? Another way is 1, 2, 3, 4. From this side, for second carbon atom, double bond is attached. From this side, for second carbon atom, the double bond is attached. Both ways, numbering system is perfectly correct. Let me retain 1. This is also correct, this is also correct, and therefore I will retain only 1. Because this compound is symmetrical about the double bond, and hence whether you number from the left side or the right side towards this side, both are same. Is it clear? How to read this compound now? Let us try to read this compound. As I said, these two are equivalent. These two are equivalent. Now I am going to read this compound. See here, longest parent chain or the parent chain is this one. Numbering is 1, 2, 3, 4. So 4 carbon atoms in the parent chain. Root word but. In is attached to. In is a primary suffix for double bond, and the primary suffix phrase in. To which carbon atom is it is attached? Just before the double bond, the carbon atom number is the one that is called a locant. See, these 1, 2, 3, 4 are called the locants. Locants means the position of the carbon atom to which the double bond, triple bond and the functional groups are attached. So, for second, the locant of the double bond over here is C2, meaning for second carbon atom, the double bond is attached, and therefore in is attached to second carbon atom. Therefore but hyphen 2 hyphen in, but 2 in is the correct way of representation of Iupac name. Of course, you can use 2-butene, meaning the in double bond is attached to second carbon atom. The locant of carbon is 2 for the double bond in this compound. So this is but2-ene is the name of the compound. For the time being, this I hope you have understood. This is but1-butene or but1-ene. This is what you can write it. Is it clear? So now first you try to understand all this, and during live session also I will discuss. If any doubts are there, I can discuss in live sessions also. Okay, I hope you have understood up to 4 compounds, 1, 2, 3, 4. That is ethene, for 3 compounds, ethene, propene and butene. In butene you have 2 structures. One is but1-ene and but2-ene. Okay, so now I'll direct you to the PPT for making the notes. Yeah, here I think all these things I have explained. Please make a note of all this. Now we look at alkynes. These are unsaturated hydrocarbons. Iupac nomenclature involves word root plus primary suffix. As alkynes contain triple bond between carbon atoms, YNE, wine, is to be added after the root word. The general formula, the molecular formula are derived from the general formula CnH2n minus 2. Here also in alkynes, the first compound starts for n equals 2 in order to have a triple bond. If n equals 2, substitute 2 in general formula C2H6 minus 2, 4. That is n equals 2, 2 to the 4, 4 minus 2, 2. C2H2, is it correct? 2 to the 4, 4 minus 2, 2. Yeah, C2H2. Here you get C2H2. How do you write the structural formula? First write 2 carbon atoms, introduce a triple bond, count the valencies for 4 and then write hydrogen on either side. Condensed formula CH triple bond CH. Iupac name, this is the longest chain, 2 carbon atoms, therefore root word eth, triple bond wine, eth, wine, ethyne. Let me discuss rest of the compounds names on the board. Now alkynes are also unsaturated hydrocarbons. Molecular formula is derived from CnH2n-2, which is the general formula for this entire alkyne series. And what else? Unsaturated hydrocarbons, naming root word plus primary suffix, and primary suffix is wine, YNE, wine. As I said, the alkynes also begin with N equals 2. Put into formula C2 H2 into 2, 4 minus 2, which is C2H2. So this is C2H2. Write the structural formula now. First, introduce 2 carbon atoms. Introduce a triple bond. Count the valencies 1, 2, 3, 4, 1, 2, 3, 4. Put hydrogen, hydrogen. Condensed formula CH, CH. CH triple bond CH. Condensed formula. Write down the name, Iupac name, longest chain, 2 carbon atoms, eth, triple bond, wine, ethine. Iupac name, ETHYNE, ethine. Next one, N equals 3, C3H, C3, 2 3s are 6 minus 2, which is C3H4. 3 2s are 6 minus 2, 4. C3H4. Next, here 1, 2, 3. Introduce triple bond, single bond. Count the valencies 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Condensed formula CH triple bond C single bond CH3. CH single bond C triple bond C, correct? CH triple bond C, CH C. Okay, we will just a moment. Single bond. Now it is correct. CH triple bond C, single bond CH3. It is correct. How many carbon atoms? 3 carbon atoms. Meth, eth, prop. Triple bond and therefore wine. Here I can have the triple bond here also. If I introduce this triple bond over here, the numbering should be 1, 2, 3. Now the numbering should be 1, 2, 3. Whether you introduce here or here, the locant does not change. Locant is that number of carbon atom or the position of the carbon atom to which the triple bond is attached. So the locant of carbon will be 1 from this side also, 1 from this side also, and therefore whether you introduce a triple bond over here or over here for 3 carbon atoms will not make any difference, and therefore this 1, 2, 3 wine, that will not at all come. It is propine. Next, N equals 4, C3, 3 2s are 6 minus 2, which is C3H4. Oh, N is equal to 4 I have to take, okay, C4. 4 2s are 8 minus 2, so 8 minus 2, 6, C3H6. C4H6, not C3. Now 4 carbon atoms, 1, 2, 3, 4. I can introduce triple bond here or here, which will not make much difference, but if I introduce in the middle, there is a difference. So let me introduce here first. Triple bond, single bond, single bond. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. hydrogen. CH, triple bond, C, single bond, CH2, CH3, 1, 2, 3, 4 carbon atoms. Now the numbering is important because there are options here, multiple options are there. So can I number this way, 1, 2, 3, 4, which is the longest chain, or is this okay, 1, 2, 3, 4, which one is correct? That numbering is correct where the locant gets the least count. Here the locant is that position of the carbon atom to which the triple bond is attached. So the locant of the triple bond is 1 here from the top. From the bottom the locant is 4. Acceptable? The locant should have a least count, and therefore the top numbering is correct and this numbering is wrong. So how do you read this compound now? 1, 2, 3, 4, but is the root word, but. Triple bond wine is attached to first carbon atom, hyphen 1 hyphen wine. But 1 wine is the name of this compound. So what happens if I change this one to this here? The compound name does not change. You try that. Now there is one option here. One more compound can be formed. 1, 2, 3, 4 carbon atoms. Here, let me introduce a triple bond here. Single bond, 1, 2, 3, 4, 1, 2, 3, 4. Okay. For this 1, 2, 3, 4. For this 1, 2, 3, 4. For this carbon atom 1, 2, 3, 4. For this atom 1, 2, 3, 4 matched, and therefore H. What is the condensed formula for this one? CH3, single bond, C, triple bond, CH3. This is the condensed formula. How do you name this one? To name this compound, first I have to number the parent chain. Longest possible chain is this. Numbering can be done from this side 1, 2, 3, 4, or this side 1, 2, 3, 4. What is the locant that has least count where the triple bond is attached? From this side for second carbon atom triple bond is attached. From this side for second carbon atom the triple bond is attached. The position of the carbon should be just before the triple bond is what we need to count. So in both the cases, for second carbon atom the triple bond is attached. So both the numbering are okay, and therefore I will retain the top one. Next, how do you read this one? 1, 2, 3, 4, root word but, hyphen, wine is attached to, the triple bond wine is attached to second carbon atom. We need to count the position of the carbon just before the triple bond. So this triple bond is attached to second carbon atom, and therefore but2 wine is the name of the compound. So here it was but1 wine and here it is but2 wine. 1 butane is also acceptable, but nowadays it is a customary to write but1 wine, but2 wine, etc. Acceptable could be 1 butane and 2 butane, no problem, but still you try to refer this is a recommended for writing the Iupac name. So alkynes, it will continue like this, n is equal to 5 also it will continue. So it will be pentine. In pentine also pent1 wine, pent2 wine, it will come like that. Okay, so now I'll direct you to the PPT and you can make a note from that. Yeah, from this alkynes, unsaturated hydrocarbons, word root, primary suffix, general formula, entire all these things write properly horizontally in your notebook and preserve it. So make a note of this. Next, one more group is called alkyl group. These alkyl groups act as substituent group. What is this substituent group? We'll see later when we study the homologous series, and when we start reading the compounds, that time we'll come to know what is this what is this substituent group, how this group is called, why this is called a substituent group. Later we'll study. Now this alkyl group, these are derived from alkanes by removal of one hydrogen atom. So what was the general formula for alkane? CnH2n plus 2 was the general formula for alkane. If one hydrogen atom was removed from CnH2n plus 2, the remaining is CnH2n plus 1, and therefore the general formula for alkyl groups is CnH2n plus 1. In many compounds, alkyl groups forms a branched group. What is a branched group? We'll see later. For the time being, understand what are these alkyl groups. Generally, alkyl groups are represented by capital R. Now, how to name these compounds? How to read these compounds? Let us take alkanes in here and alkyl groups over here. CH4 is methane, formula CH4. It is derived from CnH2n plus 2. C is equal to 1 here, or carbon atoms N is equal to 1 here. You put here N equals 1. 2 into 1 C1, 2 into 1 2 plus 1 H3, C1 H3 or CH3. So alkane will get converted to alkyl by removal of one hydrogen atoms CH3. But remember, these alkyl groups always must be represented by one vacant valency, which is a bond here. Do you understand? Here there is no free valency for carbon, but here there is one valency because one hydrogen we have removed. One arm of the carbon is remaining for accepting another atom, and therefore alkyl groups are represented with one bond and by removing one hydrogen atom from the alkanes. So the alkyl group, if I write CH3, the name of this group is called methyl group. Methane, methane, whereas here it is methyl. METH root word is kept as it is, yl is added, methyl. So methane, methyl. CH4, CH3, remove one hydrogen, it becomes bond CH3, methyl. Next is ethane here, this one, ethane, C2H6 is ethane, remove one hydrogen, C2H5, bond C2H5, name ethyl, ethane, ethyl. Next is C3H8, propane, propyl, C3H7 with hyphen, one bond C3H7 propyl. So CH4 is methane, bond CH3 is methyl. C2H6 is ethane, bond C2H5 is ethyl. C3H8 is propane, bond C3H7 is propyl. Comparing these two here all the valencies are filled, here one valency is remaining, means here this valency, that means this carbon atom is ready to attach to another neighboring atom in this case, and one hydrogen is less compared to the alkanes, and therefore if one hydrogen atom is removed from alkane, then it forms an alkyl group. The general formula for alkyne group is CnH2n plus 1, and in many compounds alkyl groups are the branched group. That means this group can be taken to and attached to the parent chain. Wherever there is a parent chain, you can take this group and attach to the parent chain, and therefore we call these alkyl groups as substituent groups or the branched groups. Okay, so make a note of this also. Yes students, I hope you have understood the Iupac nomenclature of alkanes, alkenes and alkynes, and also we saw what is the general formula and how to read alkyl groups also. Remember, alkyl groups are represented by capital R. So let us end the lecture over here, and in my next lecture I'll be taking the functional groups, and when we attach those functional groups to these alkanes, how to name those functional groups is very important. In my next class, when we talk about the functional groups, we will be talking about the secondary suffix also, because secondary suffix, the phrase of the secondary suffix should be related to the type of the functional group. Also the primary, the prefix, not the primary, only the prefix. The prefix also talks about the functional group. So in my next class, we'll study about the functional groups, what are the different functional groups, and how to name those compounds. Thank you very much for watching.